Welcome to another video. I think this is the most requested question from the JEE Advanced 2014 examination. So this is question 57 from shift 1. That's a lot of description for one problem. Now, I apologize if I don't do JEE Advanced exam problems. One main reason is the problems are usually too wordy or too big to fit on a thumbnail or to write on the board. Like, this is a small one compared to what I see, okay, in some other problems. But this was requested several times by a subscriber, and I saw the comment again requesting it, and I said, I gotta just look at this problem. So I looked at it, and it's a pretty basic problem. However, the way it is worded or the way it is constructed could be confusing. So all we have to do is find the largest non-negative value of A. Okay, and A is sitting here and here. That's it. That's all. Everything else is just basic limit computation. So they already gave us the limits. They just want us to know, to tell what the largest value of A is going to be if A is not a negative number. So let's get into the video. So after taking a good look at this problem, I noticed that the argument of sign is 1 minus x. The argument here is x minus 1, which you can write as 1 minus x, the negative version of it. So I knew I could take care of these two, but I really didn't pay attention to these other ones. Why are they there? But now I notice that this and this have a similar combination as these two. And I also noticed that what I have here is 1 minus x as an exponent. So what I did was simplify everything first, and I rewrote the limit. The limit became so easy. So the first approach I'm going to give is I want to replace the argument of sign with a single letter. So I'm going to say u. So let's see how this is going to look. Let's say, let's do it here. Let's say let theta. Okay, not u, let's use theta. Let theta be equal to, let's write 1 minus x. This means that x will now be equal to 1 minus theta. Okay, at least that's done. What else do we need to know? Well, we need to know if theta is 1 minus x, x is 1 minus theta. As x goes to 1, where is theta going? So let's look at this. As x goes to 1 in this limit, theta goes to 1 minus 1 is going to be 0. So we can change this limit completely from x going to 1 to theta going to 0. We replace all the x's wherever we have them. Okay, that's one. Let's just wait. Now, second thing is, you notice that we can rewrite this expression on top, this limit. Let's rewrite this limit, okay? We're going to come back here to fix it. I'm going to come back to what I just showed, but let's go back to the limit. So this is going to be the limit as x goes to 1 of, so what you have here is going to be, I'm going to write this first, sine 1 minus x. Then here I'm going to write minus ax plus a. But if I factor out minus a, it's going to become x minus 1. Do you see it? So I've combined this, and this is what it's going to give me, minus ax plus a, which is what I have on these ends. And I'm done with the top. And under, I'm going to have sine x minus 1. But you see, x minus 1 can be written as, see, x minus 1 is minus 1 minus x, right? So instead of saying sine x minus 1, I will be writing sine minus 1 minus x. But because, now listen, because sine is an odd function, I can pull this one out, and then I get minus sine of 1 minus x. So what is in the denominator is This guy here, I can write it as minus sine 1 minus x. Okay, now what is left? I got this guy and this guy is going to be x minus 1. That's plus x minus 1. But x minus 1 is minus 1 minus x. So I'm going to write it as minus 1 minus x. This is the same thing as x minus 1. Okay, now this is minus x minus 1, which can also be, if I pull out the minus and I want to write it as 1 minus x, it's going to be plus 1 minus x. You see that? 1 minus x. So everything looks the same. I have been able to rewrite everything as 1 minus x. Oh, except the guy, oh, this one on top is 1 minus x. But see what I want to do? Change the form in which it appears. Look, 1 minus x over 1 minus square root of x. There was something I did not address from the beginning. Can we plug in 1 directly into this expression? Well, if you plug in 1, you're going to end up with minus a plus a is going to be 0 over 0 raised to undefined, actually, because this is going to be 0 over 0. So it's going to be 0 raised to infinity or something, some weird stuff that you don't want to deal with. That's why we could not just plug in x equals 1. Okay, now let's go back here. So here, can we rationalize? Yes. But rather than rationalize, I can treat this as difference of two squares. You see, this can be 1 squared minus square root of x squared over 1 minus square root of x. You see, now I can write this as difference of two squares, 1 minus square root of x times 1 plus square root of x over 1 minus square root of x. You see that? So this takes this out, and this is what we have. 1 plus square root of x. Write it here. 1 plus the square root of x. And we say this is equal to 1 over 4. So at this point, everything looks nice and juicy until you say, you know what? What if I change this variable so that I do that substitution I had shown you initially? And I say, maybe this is not as clean as I want it to be, but I can show you what happens. Okay, so after replacing 1 minus x with theta, what will this be? Well, look, 1 plus the square root of x will be the same thing as, where is x? It's going to be 1 plus the square root of 1 minus theta. Let's go. So this is going to be, let's write the limit here now. So this is the limit as theta goes to 0 of, on top we're going to have sine theta plus a times theta negative sine theta minus theta. Nice. Everything raised to power. What will this be? 1 plus square root of 1 minus theta, which is going to be equal to 1 over 4. So what do you do whenever you're taking limits that go to 0 and you've got sine theta? And you remember that limit trick? The limit as theta goes to 0 of sine theta over theta is 1. And that's the trick. So I'm going to divide the top and bottom by theta. So every term on the top will be divided by theta. Every term under will be divided by theta. And then we take the limit. Okay, let's get rid of this. Sine theta over theta plus a theta over theta divided by minus sine theta over theta minus theta over theta. And what I have here is 1 plus the square root of 1 minus theta, which is equal to 1 over 4. Now, life is so easy because this is the limit as theta goes to 0 of sine theta over theta plus a over minus sine theta over theta minus 1 raised to 1 plus square root of 1 minus theta, okay, equals 1 over 4. So now, if we evaluate the limit as theta goes to 0, we know this limit goes to 1. We know this limit goes to minus 1. This stays as 1. This stays as a. And if we plug in 0 here, this is going to be 1 minus 0, which is 1. Square root of 1 is 1. 1 plus 1 is 2. So we end up with this beautiful limit, which is basically 1 plus a over minus 1 minus 1 raised to power 2 equals 1 over 4. Nice. And what does this tell us? Well, we don't know what this is gonna give us ultimately, but one thing we're sure of is that if we take the square root of both sides, we can have this to be a plus 1 over minus 2 will be equal to plus or minus 1 over 2. If we take the square root of both sides, square root of this is plus or minus 1/2. That means we've got two possible solutions, right? Let's multiply both sides by negative 2. We have a plus 1 will be equal to plus or minus 1. I just multiplied both sides by 2 or by negative 2, but that changes this to minus or plus 1. It doesn't matter, but let's just do it. Doesn't matter. So here we got two possible solutions. Let's use this spot. So we have a equals minus 1 minus plus 1. So that a is minus 1 minus 1, or a equals minus 1 plus 1. So a equals minus 2, or a equals 0. These will be our integer solutions, or our solutions ultimately, but there is a caveat from the beginning: find the largest non-negative a. Well, it has to be non-negative. This is negative, this is a non-negative number, and that is the only option that we have. So a equals 0 is the only non-negative solution. Never stop learning. Those who stop learning, stop living. Bye-bye.